Children, here let us see the Newton's second law of motion. We have already studied the Newton's first law of motion and its applications. So what is Newton's second law of motion? It states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. Once more I will read. The rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. So simply we can say the quantity rate of change of momentum is proportional to unbalanced force. It is the law. You know what is unbalanced force? You know what is rate of change of momentum? Rate of change of momentum is a quantity which is obtained when you divide change in momentum with the time. That is rate of change of momentum equal to change in momentum divided by time. What is change in momentum? If we want to find change in a particular value, we have to subtract the initial value from the final value. Therefore, change in momentum is final momentum minus initial momentum. Change in momentum is final momentum minus initial momentum. Therefore, rate of change of momentum we can rewrite rate of change of momentum equal to, instead of change in momentum, what we can write? Final momentum minus initial momentum divided by time. Next, let us see what is the mathematical formulation of second law of motion. We can derive an equation for second law of motion. Instead of second law of motion, Newton's second law of motion, we can write an equation. We can express Newton's second law of motion using an equation. What is that equation? Let us see here. To get the equation, first you consider a car of mass m. The mass of the car is m. It is moving with an initial velocity u. We know the initial value of velocity is represented using small letter u. Then suppose a force F applies on it for a time interval of t. As a result of this force, the velocity of the car changes to v. That is, final velocity is v. This is the case. Here is a car having mass m. It is moving with the initial velocity u. Then a force F is applied for a time t. Then its velocity changes to v. So here we can list out the terms. Mass of the car is equal to m. Its initial velocity is equal to u. Its final velocity is equal to v. Force applied is equal to F. And the time is t. We are going to get an equation for Newton's second law of motion. What is Newton's second law of motion? Rate of change of momentum is proportional to force. Okay. So let us first find out rate of change of momentum. What is rate of change of momentum? It is change in momentum divided by time. So first let us find out change in momentum. So what is the value of initial momentum? Initial momentum we can represent using P1. You know momentum is represented using the letter P. Therefore, since it is initial momentum, let us use P1. And what is momentum? Momentum is mass into velocity. Since it is initial momentum, let us write mass into initial velocity. Therefore, P1 equal to mass, we can use the letter m to represent, and for initial velocity we can use u. Therefore, m into u, you will get P1 is equal to mu. Similarly, let us find out final momentum P2. That is mass into final velocity. That is final momentum. Or P2 equal to, instead of mass we can put m. Instead of final velocity we can put v. M into v, you will get mv. So we have got initial momentum and final momentum. Next, let us find a change in momentum. What is change in momentum? It is final momentum minus initial momentum. That is, change in momentum is equal to final momentum P2 minus initial momentum P1. Or change in momentum is, what is the value of P2? Final momentum P2 is mv. And what is the value of P1? Initial momentum P1 is mu. Therefore, we will get change in momentum is equal to mv minus mu. Next, what is Newton's second law? Force is directly proportional to rate of change of momentum. This is the symbol for proportionality. You know how to write equal to symbol, how to write, you know. Similarly, this red color symbol is for proportionality. It is read as force is proportional to rate of change of momentum. Force is proportional to rate of change of momentum. But what is rate of change of momentum? It is change in momentum divided by time. Therefore, we can write force is proportional to change in momentum divided by time. The meaning of this proportionality is, let us consider separately. Force is proportional to change in momentum. Here change in momentum is in the numerator and time is in the denominator. So if we consider separately, we can read force is, when we say about the term in numerator, that is change in momentum, it is the term in numerator. We will use force is directly proportional to change in momentum. Force is directly proportional to change in momentum. And when we say about the time, it is in the denominator, we will read it as force is inversely proportional to time. Together we can say force is proportional to change in momentum divided by time. It is force is proportional to change in momentum divided by time. Separately saying, we can say force is directly proportional to change in momentum and force is inversely proportional to time. That is, for the quantity in numerator we will use directly, and for the quantity in denominator we will use inversely. Altogether we say force is proportional to change in momentum divided by time. Separately we will say force is directly proportional to change in momentum and force is inversely proportional to time. Then what is the meaning of this directly proportional and inversely proportional? Directly proportional means when change in momentum increases, force also increase. Or when change in momentum decreases, force also decrease. That is change in momentum. What is the meaning of inversely proportional? Inversely proportional means when time is increased, force is decreased. Inverse proportionality. And when time is decreased, force is increased. Inverse proportionality. When it comes numerator, it is direct proportionality. It is about the proportionalities. Anyway, here we have got force is proportional to change in momentum divided by time. So let us write the equation. We have got force is proportional to change in momentum divided by time. Force is represented using F. Proportional to What is change in momentum? We have got change in momentum is equal to mv minus mu divided by time is t. F is proportional to, force is proportional to change in momentum mv minus mu divided by time. You can see here in both the terms mass is there, therefore we can take mass outside, therefore we can rewrite F is proportional to m. You take mass outside into v minus u by t. What is this v minus u by t? You have studied in the first chapter. V minus u by t is equal to a acceleration. It is the expression for acceleration. V minus u by t. Change in velocity divided by time is acceleration. Therefore, instead of v minus u by t, we can put a. Therefore, force is proportional to mass into, instead of v minus u by t, acceleration. Now we have got this expression, force is proportional to m into a. Now here it is proportionality sign. To remove this proportionality sign, we need an equation now. In equation there should be an equal to sign. Therefore, to remove proportionality sign, we can put a constant there. Then replace proportionality using an equal to sign. That is, proportionality sign can be replaced by equal to sign, putting a constant k there. This is how it is written. The proportionality sign is replaced using equal to sign, adding a constant k there. K is known as constant of proportionality. Its value is 1. Therefore, this equation F is equal to Kma will become F is equal to Ma because K is equal to 1. This is the equation for second law, Newton's second law. F is equal to M into A. F is force, M is mass, A is acceleration. Next, let us find out the unit of force. We know the equation for second law, F is equal to M into A. Okay. Now to find the unit of force, let us substitute the unit of mass and the unit of acceleration. What is unit of mass? It is kilogram. What is unit of acceleration? It is meter per second square. Therefore, unit of force is kilogram meter per second square. Kilogram meter per second square is otherwise known as Newton and represented using capital letter N. Then let us see what is 1 Newton. If you put mass is equal to 1 kilogram, acceleration is equal to 1 meter per second square, you will get force is equal to 1 Newton. 1 into 1 means 1. Okay. Therefore, it is the 1 Newton is the amount of force that produces an acceleration of 1 meter square in an object of 1 kilogram mass. Next, let us get Newton's first law from Newton's second law. Let us find out Newton's first law from Newton's second law. What is Newton's second law? Force is equal to mass into acceleration. Now, what is acceleration? You know equation for acceleration. A is equal to V minus U divided by T. Substitute here. Therefore, we can write F is equal to mass into, what is acceleration? V minus U divided by T. Then you bring this T from RHS to LHS. Then it will become F into T equal to M into V minus U. Suppose the force is equal to 0. Therefore, here LHS will become 0 into T. If F is equal to 0, it will become 0 into T equal to 0 itself equal to mass into V minus U. If mass into V minus U is equal to 0, you know mass never can be 0. Therefore, which value will be 0? V minus U will be 0. Therefore, we can write V minus U equal to 0 or V is equal to 0 plus U or V is equal to U. We will get the final result V is equal to U. Because mass never can be 0. Therefore, we got this result when we substitute F is equal to 0. Therefore, when there is no applied force, V equal to U. What is V? What is U? It is initial and final velocities. Therefore, initial and final velocities will be same. That is, velocity will not change. Velocity will not change means if suppose the body is initially at a rest, that is U is equal to 0, initial velocity is equal to 0. Then what will be final velocity? It also will be 0. That is, the body will be at a rest itself. When? If force applied is equal to 0. That is, the body will continue the same state of rest if there is no force. Suppose initial velocity U is equal to 10 meter per second. Then after some times what will be the final velocity V in this case? It will be again 10 meter per second. Since force is equal to 0. Therefore, the body will continue the same motion. Since the force is 0. Which law is that? It is Newton's first law, na? If the force is not there, the body will continue the same state of rest or uniform motion. So, we have got Newton's first law using the equation for Newton's second law. We have got this result from the equation F is equal to ma, that is Newton's second law.